Effect has been on my radar for a few months now, but I've continuously put off learning it because I know that the learning curve is very steep. But a few months ago, I decided to dive pretty deep into this library, and I can honestly say at this point, it's officially consumed all of my server-side TypeScript. This library has actually caused me to reevaluate the way I structure my projects. So in this video, I'd like to share why Effect is so compelling and also showcase how I use it in production today. So with that said, let's say you're building a basic web service. This web service needs to connect to a database. So you build out a database singleton that creates a single instance of a database client that can be used throughout your app. Now there's nothing inherently wrong with this approach. But from my experience working at a larger company, there is a severe lack of standardization in TypeScript projects when it comes to managing dependencies like databases. The lack of standardization is most apparent when you start looking at test cases. You'll basically see various test files with the same mock boilerplate, and then you'll see test cases that reference the mock implementation of a service. And in better code bases, you'll see an attempt to treat a database as a dependency for a domain-specific service, which does make testing cleaner. But now it is up to the developer to determine how they should use the service. Do we provide the service right before using it? Imagine the bloat if you have multiple services. Do we provide the service at the top level of files when the service is used? Or do we follow a more structured approach where all the services are instantiated in a single file and used across the codebase? If you have worked in a large TypeScript codebase, you have probably seen a combination of these approaches within the same project. Even in the most well-structured codebases, I often find myself thinking, I know this isn't an incorrect way of building a service in TypeScript, but it doesn't feel quite right either. But once I started to really dive into effects patterns for managing dependencies, I finally had the aha moment where I thought, this is the way. So building on this example, let's see how we implement the same database service in Effect. We'll start by creating a database service that extends the effect context tag. This service will have a query method that returns an effect. Once we have a service definition, we can actually start writing our application code even without an implementation of the database service. We can define a simple program called getUsers that queries the database and returns users. Now there is a chance that you look at this code and think, why the heck is there a function with a star and the word yield inside the program? Just for the time being, let's ignore this and focus on the fact that all we have is a service definition of a database. It is not a live database. We have not provided any connection string. And yet we are able to write actual type-safe logic that uses the database. And we didn't need to leak any of the database implementation details into the program that uses it. Now realistically, the database service will probably come from an actual database service provided from Effect. You won't write your own, but you will probably create a number of domain-specific services, like a user service or an email service. Note how there are very clear input and output types in these service definitions. I have found that when you build with Effect, you start to think more critically about the responsibility of each service, and it forces you to think more clearly about your input and output types. The end result is that you are able to build out large sections of your business logic before you write granular implementations. Like in this example, we have an actual program called register user, which uses the unimplemented user service alongside the email service that has no implementation. Now, in order to execute this code, we'll need to provide the actual implementations of all the dependencies. You can think of the last line of this code as an oversimplified version of an entry point to your application. This code block in the current state will raise an error. Your LSP will complain about the missing implementation of the user service, email service, and database service. And if you try to build your project, it will fail. So to get this program to run, let's create the implementation of the user service. Notice that the user service depends on the PG drizzle service. You'll typically use layer.effect when a service depends on another service. The layer takes our user service definition, and then we'll provide an effect that returns the implementation of createUser. This code is also type safe. If our implementation doesn't return the correct types, the LSP will complain and the project will fail to build. We'll also create our email service, which calls our email client, and we'll create a live implementation of our database service by wiring in the connection details. We can finally provide our services to the entry point of our application. Now, if you read through the effect docs for managing dependencies, you'll see a few different patterns and examples. But what's most important to understand is that Effect provides a pipe operator that allows us to chain programs together sequentially. Since the user service depends on the database service, Effect will complain if the user service is not provided before PG Drizzle Live. Oftentimes, your project will have far more dependencies than this example. And when you have dependencies that depend on other dependencies, you'll likely want to merge dependencies together so you can better understand the hierarchy of your dependency graph. If you are new to Effect, I know that this seems like a lot. There's definitely a lot to learn, and it will take a decent amount of effort to really understand. But to quickly recap, we design the definition of our services by extending the effect context. These services represent higher level concepts within our application with very clear input and output types. We can then use these services to compose actual business logic before we even create actual implementations of our service. Then we create the live implementations of our services. And finally, we provide our implementations to the entry point of our application. After a few months of using Effect, I found myself putting more effort into modeling out the core domains and concepts within my application. And the end result led to more clean, modular code that is easy to extend. It also provides patterns within your application that are very easy for AI to pick up and replicate. So now that you have a high-level understanding of Effect services and dependency management, let's take a quick look at the core features we have access to when we run Effectful programs. When providing services to the entry point of our application, we touched on the pipe operator. The pipe operator is like a gateway to an endless number of features when building out implementations. For example, if we take a look at our register user program, we have two core operations, create user and send email. Let's pretend that there was a network error when running create user. Traditionally in Typescript, we would probably have a try-catch block to handle this. And if we wanted to retry the operation, we'd probably have to hack together some solution under the catch block. Now I know that there are cleaner implementations if you're not using Effect, but look at how clean and simple this operation is in Effect. We can simply use the pipe operator to pass in an Effect retry. We can simply specify the number of times that we want to retry until the operation fails. Effect has a ton of features around retry schedules, so I think it's worth going through the docs to understand what's available. But the key takeaway is that you can easily compose effects together using the pipe operator without having to leak implementation details into the core programs. So now that we have seen the basics of Effect in use, let's take a look at the actual effect type. The effect type is a description of a workflow or an operation that is lazily executed. This means that when you create an effect, it doesn't run immediately, but instead it defines a program that can succeed, fail, or require some additional context to complete. The effect type provides three core channels: the success channel, the error channel, and the requirements channel. The requirements represent the dependencies that are used within the effect program. The success channel represents the result of the effect, and the error channel represents different types of errors that can occur during the execution of a program. Effect is unique in that it allows you to define explicit type-safe errors. Within our application logic, we can explicitly yield these domain-specific errors that we have created. In this specific example, we're yielding a domain-specific error called user not found error, but there are also other errors in this program's error channel. There are possible network errors that can occur during the fetching of this request. It's possible that we expect to yield JSON, but the server provided non-JSON data. And if we do get data back, it's possible that the server provides data that doesn't match the exact schema we expect. When we use the getUser program, we can decide specifically how we want to handle logic based upon these errors. We may want to catch the user not found error and create a user so we can recover the program and continue execution. As you can see, tagged errors can be very powerful because we can build out our own type-safe error handling strategy within our application. Now at this point, we've covered some core concepts of Effect at a very granular program level, but I think it's very important to also understand how Effect is used at the application level. Now I personally run Effect in two different ways. One, I integrate it server-side into existing full-stack applications like Typescript. Or two, for when it makes sense, the best solution is writing a pure Effect app that leverages Effect's provided HTTP server. For the first point, if you are incrementally adopting Effect into an existing Typescript project, I have found that it's best to push the Effect logic as close to the entry point of the server-side execution as possible. This way you are not jumping continuously back and forth in between Effect and non-Effect code. In Typescript, I like to create middleware that sets up an Effect runtime with all the core dependencies needed for the server-side code. I then provide the run Effect handler in the context of the middleware. This allows me to create server functions that have a very clear step from non-Effect code to Effect code, where I'm able to pass in an Effect program that handles all of the server-side data processing entirely in Effect. And this middleware also works for Typescript server handlers as well. But do note that this middleware is designed specifically for the Cloudflare runtime, and if I were to just be running this on Node, I'd set things up slightly differently. Now this setup works pretty well for me in Typescript, but if you're able to run a pure Effect service for your use case, things become a lot cleaner. You can check out this template that I built to see these examples in more detail. This template showcases two Effect services, one built with Effect RPC and the other with Effect HTTP groups. Both of these projects follow essentially the exact same design, so we're just going to focus on the Effect HTTP groups for now. In this monorepo, we have a package called contracts. There's an HTTP folder that contains the HTTP groups. Each HTTP group defines a set of routes with the expected input, output, and error types. These types are actually Effect schemas, similar to Zod schemas, that are used to validate data coming in over the wire. I call this package a contract because it defines the behavior of the API, but it doesn't provide any implementation. The implementation lives in the Effect Worker API app. The implementation is just a simple handler that handles each of the endpoints defined contract. The handlers are simply responsible for processing the business logic, and the contract handles all of the schema validation for requests coming in over the wire. We will then provide the live implemented handlers to the entry point of our application as a dependency. Now note that this project has been set up to run on Cloudflare workers, so it will differ slightly from other Node or Bun-based setups. I do plan on going deeper into the topic of running Effect on Cloudflare workers in a later video. But if you're curious about the setup right now, simply clone the repo and ask Cloud Code about it. I have documented the code pretty extensively, so AI should be able to break it apart rather easily. So these are the templates that I've used in production for the last 3 months when running Effect on top of Cloudflare. Since Cloudflare is my go-to compute platform, I've also built some abstractions on top of durable objects, and I've published a package called Durable Effect. I really wanted a clean way to run Effect on durable objects, and I also wanted to reduce the boilerplate required when getting a durable object set up. I do really want to share more about this package later because it's currently powering a lot of cool use cases for me at the moment. I personally wouldn't suggest using this package at the moment, as the API will likely change due to the fact that Effect is going to be releasing v4 in the near future. But if you're interested in exploring some novel solutions built on top of Effect, I do think that this is a pretty cool codebase to look into. To conclude this video, I just want to say that learning Effect is almost like learning a new programming language with a very fat standard library. It's awesome that Effect provides so many things out of the box for us, but it does make the learning curve very steep. So if you're new to software engineering and you find this video to be overwhelming, I'd suggest spending your time mastering the Typescript ecosystem first. Once you understand Typescript well enough to feel the pain points that Effect addresses, I'd say that's when you should start investing your time into learning Effect. Now, on a personal note, I did find making this video to be rather challenging because it's really hard to distill Effect down to core concepts because it is such a big library. So if you're interested in seeing more Effect-based content, please do help me out by sharing the different topics you'd like me to cover. It really helps me gauge where the interest is at and people's familiarity with Effect to begin with.